That for the people that were live here, so I think we're back streaming. So we still have performance issues. Still got to keep working on that. So so let me just wrap up some of the conclusions on the splitting and the training data. So so I'll let you guys read through this section on your own. There is some subtleties to this. So the big one, and again, I think we use this in the third assignment or the fourth assignment. So sometimes you can't just do a random sample because you have to be careful that everything that you need is fairly represented in the sample. Okay, so this is getting into, if you've ever taken a course on polling or sampling, so like political polling, it's the same issue here, right? So if you want to take a political poll, you have to be careful of the people that you poll, that you sample, that they're representative of the population that's going to end up ultimately voting in an election, right? Or whatever it is you're trying to sample. Same idea here. So sometimes we have to do like when we're doing our split, we have to do some sort of stratified sampling. So we want to do something like, for example, make certain that in our test set and training set, we have the same proportion of important features or the same proportion of the labels that we're trying to predict. Okay, so that's the main idea of this stratified sampling that they talk a little bit about here in the chapter 3 here. So yeah, let's jump over to the data cleaning, the data preparation stuff. Say a few words about that, and then I wanted to maybe look at the stats model a little bit today as well. So once you have a handle on the data that you want to use and you want to model, usually you want to you'll have some idea of what you're going to try to do, what you're trying to predict. There'll be some things that you'll obviously need to do. So you might have to do something to handle missing data. You'll have to do something if you have non-numeric values to do something with the non-numeric values. Usually, if those are categorical, you'll want to change those into category variables. So those are the two main. Oh, and the range. If you want to use a model that's going to be sensitive to the range of your data, you'll probably want to scale your data, right? So those will probably be the three main ones that we'll talk about. And in your project for the class, those will probably be the ones that you want to think about. Is there any missing data? If there is that feature important enough that I want to keep it and do something to fix that missing data? So that's the first thing that we'll talk about here. If that feature isn't very important, we could always just get rid of it, right? So if it doesn't look like it's going to help in our model, it's not very highly correlated, we could just drop it, right? So that's really what. There's two kind of things. So if only a few of our samples, so if only a few of the rows in the database have a few missing values, we can maybe just get rid of those rows, not consider them, right? If there's a lot of rows, and the other way, right? So the thing I started talking about was for a particular feature, a particular column, if there's not a lot of missing, or if there's a lot of missing, or if that feature doesn't look like it's going to be important, we could just drop that feature, not use it in our model. But if neither of those is true, so the reason why these first two are often not good options is the more data you have, the better model you can ultimately make, right? So it's painful to have to leave any data on the table, to just drop it and ignore it, right? So it's common, if those two things don't seem like a good route to go, it's kind of important. And there's too many that if I got just rid of all the ones that are missing, all the samples that are missing that, I would lose 10% of my data or something. We might want to try to make up. So predict. So this is really kind of a prediction we might want to fill in those missing values, right? So we can't just fill them in with 0 or so a common thing, first thing to try is like the simple imputer. And yeah, I think you have to use this for the second assignment at one point here that you're working on right now. We might just take the mean of all the non-missing values or the median or some other, and just use that for the missing one, right? So that's, if we don't know anything else about the missing value, at least we have something that won't be too, since the mean is the typical value, it shouldn't be too far off from what the actual one is that's missing. And you can get more complicated, so you can turn that into a mini machine model, a machine learning model, right? So you can maybe use some other features that you have to try and predict that missing value, to use that to fill in, if it's really important, right? But yeah, so there are. So this might be the first time where we're starting to use some Scikit-learn stuff here, right? So we'll be using the Scikit-learn library a lot in this class. So it has, it has not only things in it which are, the models, things for building regression or classification models. It has lots of other tools for doing data exploration and data cleaning. So like we're showing here. We can just use a simple imputer, and if we look at this, it has different things you can do. So in fact, maybe I'll mention the help strategy again here, or the help system. So I usually use the, I think you can pull it up. I'll probably have to rerun this notebook. That might cause me to lose my performance again, but let me rerun this notebook just to ensure. So the help system won't work unless it's actually loaded in all of these. So these cells have been run. So it's got in memory the import of the simple imputer and the other stuff, right? So, but if I've run that cell, you can always use contextual help inside of Python notebooks. And I haven't used it in VS Code, but I assume that you can get to the contextual help in running a notebook in VS Code as well. So if we look at the show contextual help, close this off here so I have a little bit more room. We should be able to, when you're within the context, it'll figure out the context and it'll pull up the documentation. So this, I forget if I mentioned this when I was reviewing assignment 1. So one kind of requirement that I'm asking people is you should always have the PyDoc documentation. So that's the documentation side of 3 strings, really just a big string. But right after the declaration of the class or the function, and the standard for PyDoc documentation is you should have a description, you should document all the parameters that are input into the function, and you should document the return value. And so, like in Scikit-learn, they also have additional things. So you have to have all these sections, notes and examples and stuff like that, right? So I want people to at least have a description. So I usually give these to you, but if there is a thing where you have to write a function from scratch that you aren't given, you should provide at least basic PyDoc documentation. And this is one. So this is kind of built into the Python ecosystem. So, if I need help, there's various ways to get it. So here we're just pulling up the PyDoc documentation for the simple imputer. I did that because I kind of wanted to know what other strategies. So besides the mean and the median, we can just, whatever the most frequent value is, we can just fill in missing values with the mode. So if you know what the mode is in statistics, that's the most frequent is the mode. You could just have a constant value, like you could just fill them all in with 0 or something like that. All right, but yeah, I make a lot of, instead of Googling stuff, I often just make use of the contextual help because you can at least get an idea of, for each of what parameters you can use when you're creating a function or creating a class, an instance of a class, or calling a function, and what the values are that function, that parameter supports or takes, right? So very useful for saving time to use the help system. All right. So in this notebook later on, right here, so the API design. So we'll see that this is the common pattern. So, the Scikit-learn is extensively used in Python for machine learning. It is the for in any language, it is the preeminent tool in the space. Okay, one of the reasons why it's so popular, it has a very clean design. So once you learn kind of the pattern of how to use things, you can use most anything in the Scikit library, a Scikit-learn library. And this is a discussion a little bit of that, right? So there's kind of three main sorts of things: estimators, transformers, and predictors. And I probably shouldn't go into the details of all these things here, but so basically, real quickly, what we showed on the imputer is this is the particular pattern. So you create an instance of something that will do some sort of a transformation, so some sort of a cleaning in this case. You fit that estimator to the data that you want to clean or transform in this case, and then once you fit the data, for a transformer, you call transform. Okay, so we fit this imputer using where we want it to impute using the median value, and then when you call the transform, it will actually, in this case, it will take that feature and create a new data frame that has filled in the missing value in this case. Okay. So so this was just proof of that. So the total bedrooms was the only one that had some missing data. So now if we look at and notice we're also looking at just the training set. So after we did the 80% training test split here, we've got 16,512 items in our training data set, and they are all filled in now because we filled in the missing data using that computer. All right. So and I'll talk more about the API design later on, although maybe next week. So besides missing data, another important thing is, so some of the attributes might not be numeric when you read them in, and you might want to use them. So the most common one you want to use is something that's really a categorical variable. Right. So what we mean by categorical is it just has a discrete number of actual values, right? And the simplest is it's binary, so it's a yes, no, or true, false category. But like in this case, we can have a categorical variable that has what was it? 5, 1, 2, 3, 4, 5 different categories, right? But anytime you have a small number, 5, 10, 20, but of discrete, unique values, you usually want to treat it as a categorical variable in machine learning, right? But when we first read this in, these were really strings, so we have to do some cleaning to create a categorical variable from it. So the simplest is just to encode it as an integer, which is what the ordinal encoder is doing here. And you have to use an ordinal encoder on the assignment that you're working on right now. Right? So here it just maps zeros to I can't remember, but 0, 1, 2, 3, 4 to the 5 categories that we have here. All right. And again, it's a transformer, so we can fit and transform. And there's a convenience method that will do the fit transform all in one step. So really, this just calls fit and then calls transform for you. And here we can see the mapping that it did, right? So it ended up mapping 0 to the less than 1 hour from ocean, 1 to inland, and so on. All right. But sometimes, so if there's a natural ordering to the categories, you don't want to have like a random mapping, okay? So here, it's the thing that's the thing that's on an island is probably is right on is right by the ocean, right, versus near ocean is maybe close but a little bit further away, or near bay, right, and then less than water from the ocean is further away than that, right. So there's a natural kind of ordering to how close you are, and that probably makes that's probably an important distinction in this case, because we expect that things that are close to or right on the oceanfront property are going to be more expensive housing, right? So it might be useful for our predictor. So if there is an ordering to these numbers, we want to keep that, because that will help our models make predictions about things. So you can specify how you want to do the mapping for the ordinal encoder. So we're showing that here. So we want island and near ocean and near bay to be 0, 1, and 2. And then less than ocean and inland to be 3 and 4, so further away, right? But that's all we showed here. So you will use that at some point for an assignment as well, whenever possible. So sometimes you have a categorical variable that there's really no inherent ordering, and then it doesn't matter if you just randomly map them to an integer. But sometimes it does. So yeah, we talked about that here. So if your category is just a job type, salesman, receptionist, there might not be any real order to that, versus there is kind of an order to your year in college, freshman, sophomore, junior, senior designation, where this is first, second, third, and fourth. So okay, and still got 10 more minutes. I think So we'll come back to the last part here if we need it. So there's some more advanced examples of doing some custom transformers. So I'll leave that for people to look at. Let me just spend maybe 10 more minutes. So there is a notebook, a fourth one labeled Unit 3 in the main lecture subdirectory. So for the assignment 2, we're going to be using regression from Scikit-learn, and also creating a regression model using stats model. Okay, so really probably the notebook, if you haven't looked at this one yet, this will give you the most hints, the most direct examples for that part of the assignment 2, where you're asked to, for the first part of assignment 2, where you're asked to perform a regression, first using Scikit-learn and then using stats model. Okay, so I've only got a little bit more time left, let's just look real quickly at for Scikit-learn. So if we have a data set, so this isn't the same housing data set, but a similar idea. We're going to try to do a regression. Here we've got house prices of individual houses and similar information though, like income and number of bedrooms for that house. And we want to build a model to predict the house price in this thing here. So after some data cleaning, so if we're trying to predict the house price, we need to get that out of. So what I normally ask you to do in all of the assignments for the class is, we'll just by convention, we will use an array or a data frame called X that has all the features we're going to use to build a model with, right? So at this point here, we need to have in X numeric features that we're going to use to create a regression model with, right? So that's why I think we maybe did some cleaning for some other stuff if you read through this beforehand, but then we still had the price of the house in here, so we removed that. So now X has these features which should all be numeric or categorical. We can use that to train a model with. And then by convention we use a plain vector or a plain if it's pandas, then it would be a series. So series holds like a single feature, a single column in pandas. So so anyway, yeah. So we just pull out the price, and we're going to use that as the label that we try to predict here. Right? So I don't think we did any train test split in this example, and I don't think we asked you to do that on the second assignment. But you would probably first split this into train and test sets, and then you would create your X on the training set and your Y on the training set. So I already mentioned the basics of using fit transformers in Scikit-learn. So all of the actual models that you want to build, regression models or classification models, have that same pattern. So you create an instance of it. So here, usually when you create an instance of it, this is where you would specify metaparameters. So I think, again, I just want to bring up, let's look at the linear regression real quickly here. So if I bring up the help system to get an idea of cells are still running here, so it's still trying to load some stuff. What's it doing? There it goes. All right. So now I have my linear regression. I still haven't finished running all the cells in the notebook here. There we go. I think we're done. So there. So now if we have our linear regression, so for the second assignment, you're not supposed to change any of these parameters, but later on we might have to change. Yeah, the linear regression doesn't have any interesting ones, so you can specify whether to use the intercept parameter, whether you have an intercept parameter or not, some other stuff here. So anyway, when you create a model, so here for fit transformers that are building a model of a set of data, you basically pass in your features as an array or a pandas data frame X, and then the labels that you want to predict, either regression labels or categorical labels if you're doing a categorization for Y, and fit that. Right? And then what you'll need to do for the assignment 2 is I'll ask you to do things like find the coefficient, so find the parameters of the model that was fit, the coefficients, the intercept, at the end. So once you have a fitted model, then you can make predictions. So you can pass in unseen. So in this case, we're passing the data we trained with to make predictions on, but you can also pass in data you haven't seen before to make new predictions on unseen data. And likewise, so I kind of ran out of time here, so maybe I'll come back to this next week. But we are doing both linear. We're doing both a linear regression and a logistic regression. So the name's kind of bad, but this is just convention. But linear regression is really a type of classification. So, but the pattern is the same. so for the second part of your assignment, you're going to do a logistic regression. So you're going to do a classification task using the Scikit-learn logistic regression. And then finally, stats model is just another library. It's not used as much. The difference is the stats model library is really for people that are into statistics. Okay, so statisticians use stat model, whereas people that are doing machine learning in the areas have a lot of overlap, but they're distinct. So, but I'll just point out. So the API is a little bit different. So to do the linear and the logistic regression using stats model, you want to import the stats model API like this. There is this thing I have to talk some more about. So by default, it doesn't add in what's known as a linear regression constant to the data that you pass in. So before you can perform a linear or a logistic regression using the stats model library, you have to by hand call this method to add in a feature. Right? We'll talk what that means. Actually, when we learn about the details of linear regression, you'll get a better handle of why one library does this and the other one doesn't do this by default. But then, you basically fit a model in a similar way, do a fit transform, although it's called OLS, which stands for the ordinary least squares, which is the same as a linear regression. Although for reasons, again, this is the way that statisticians think about this. They pass in the targets first instead of the features, and then so they reverse those. So be careful about that when you're working with the stats model. It expects the targets, the labels first, and then the input X second. But then a nice thing, so this is the thing that most statisticians want. They want this information about the R squared and the value of the fitted model, but especially they also want the p-value and the the p-value of the fit for each one of the parameters and stuff. So we'll go into more details of that. So yeah, I did run out of time. We'll come back to this, but like I said, so those are the resources that you guys should be using. Hopefully that's enough to get you started. If you haven't actually started doing work on the second assignment, you really should have accepted it by now. You probably should start trying to work on stuff to make certain that that you won't have problems getting things done. But you do still have a week from tomorrow to get stuff on. We'll talk about the details of it, of the actual stuff you need to do next week. So I did have a question. Sorry for not answering this when I first saw it. So the deadline for the final project, I'm going to make a deadline here in a little bit for you to select a data set and claim the data set you want to use. But we still have, I'll do that before our midterm, but next week I'll set a deadline for that. But the actual deadline for the full final project will be during finals week. And I'll ask people to submit it by Thursday of finals week, so I have Friday to go over those and evaluate them. So. All right, yeah, that's it for today. Sorry for the people online, as again, my live stream sometimes lags a bit and went down today, so I'll keep working on that. But I'll see you guys hopefully next week then.